Hello, everyone, and welcome to Unlocking AI's Potential, the role of a modern data ecosystem. I'm Molly Colwell, and I'm an application engineer here at DataPARC. I'm joined today by Scott Carey, and I'll go ahead and let him introduce himself.
Yeah, thanks, Molly. I'm Scott Carey. I'm a sales engineer here at DataPARC as well. Excited to be here today and to talk about this subject.
A bit about DataPARC. It's a performance-focused industrial data platform used by manufacturers around the world. With powerful tools for trending, visualization, and analytics, DataPARC helps teams across industries connect their data, uncover insights, and drive better decisions. And today we're excited to share what is needed to build a data ecosystem that builds meaningful AI applications in manufacturing. If this is your first webinar with us, here's a quick overview of our formats. The DataPARC University sessions are training focused and walk through step-by-step products and use cases. These are available on our DataPARC community forum. The industrial insights, like today's session, focus on operational and strategic topics in manufacturing, particularly around data and decision making. The solution spotlights highlight broad use cases, often with customers, and show ways DataPARC is used to solve real-world examples. Um, these are often available on our YouTube channel. Some final housekeeping before we get to the topic at hand. We encourage you to ask questions throughout the session using the Q&A panel. And at the end of the session, we'll have some time to answer questions. Any questions we don't get to during this session will answer via email and will be posted in the YouTube comment section with the recording. Let's jump in. So on today's agenda, we'll cover setting the stage, a little bit about where manufacturers are today, and some common pitfalls we're seeing. Then we'll go into what makes a healthy AI-ready data ecosystem and what that actually looks like. We do have a real-world example for you with using predictive maintenance, and then we'll touch on how DataPARC can support this journey. We'll wrap it up with some key takeaways and Q&A. So for setting the stage, why your data ecosystem matters. Most everyone can agree that data is going to be the foundation of AI, but it's important to call out that it's not just any data will do. It's the strength of your data ecosystem and how it's collected, organized, and maintained that directly impacts the success of your AI efforts. When data is disorganized or inconsistent, AI models are going to struggle to find the right signals. This can lead to failed projects, frustration, and in many cases, a loss of confidence in your system. And once users lose the trust in the results, adoption is going to tend to stall. Another issue we often see is the data is spread across multiple disconnected systems. And this creates a barrier to analysis and overwhelms teams, especially when they're tasked with stitching together all this inconsistent data sets. On the other hand, when your data is centralized, clean, and accessible, you are going to unlock better insights and smoother implementation. So you need to reduce your manual work required to prepare your data and give your models the best chance of success. One key enabler is using a consistent logic naming convention or an asset-based data structure. And this can make your historian data easier for AI models to interpret across and scale across equipment or system. But not only AI models, for people as well. So instead of just having the stream of raw values, you're building a structure, a trusted foundation for analytics and for proactive decision making. It's also important before you venture into your AI journey to determine what data stage you're in. So we like to think of this in levels 1 through 5. At level 1 or 2, you may have a lot of data, but you may not have access to it. It could be siloed or unstructured and lacking context. And then in level 5, your data is going to be fully organized, contextualized, and accessible. That's where it's ready to support scalable AI use cases. Most manufacturers today are still early in this journey, and that's okay, but it's important to recognize where you are to help set realistic expectation, to give you a clear path forward. You can't jump from level 1 to level 5 without doing that groundwork. And that groundwork is all about organizing and contextualizing your data and getting the data if you don't have it. That is where this asset-based tag structure is going to come in, and your data is going to be organized around assets. It becomes much easier for both humans and AI models to understand those relationships and patterns. That clarity makes it scalable and repeatable and far easier to maintain long term. As you think about AI, start asking yourself, how is your data structured? Do you already have context, structure, and consistency across the board? And where do you need to begin? What stage are you already at? And then just some pitfalls to watch out for where we're seeing AI sort of fail right now, or how we're seeing AI initiatives not meet expectations. The first is going to be the lack of data readiness. One of the biggest culprits. So AI models require structure, and if you're feeding raw data or incomplete data, you're going to get unreliable outputs. And the results are going to be difficult to trust and act on. We've all heard garbage in, garbage out, and that's where this is going to be coming from. The next is going to be minimal involvement from a subject matter expert. So trying to use these models without having the technical work put in. But without this operational input to validate the use case or interpret the outputs, it's going to consistently miss the mark for real world environments. This is much like statistics, when something can be statistically significant but not practically significant. And we can see the same with AI outputs as well. So you need to keep that in mind and make sure the subject matter expert kind of is there. We're also seeing common issues with inflexible or siloed systems. So if your data is scattered across multiple platforms, it's really hard to align and access that data. Integration is a huge barrier, and scalability really suffers. So even if your model is going to produce good results, it might not also have a strategy to apply those insights. If you have 6 or 7 different applications, where are you going to reapply those insights? Is it application A, B, F? You don't quite know where you're going to see that information. And you have a lack of cross-functional collaboration. AI projects often span between IT, OT, operations, but those groups might not be aligned on the priorities or the timeline or what success looks like. So making an effort for aligning your goals can help maintain momentum instead of losing it. Another challenge we're seeing is an over-reliance on the model itself. Often, the belief is that the model will just figure it out. Just plug in the values, give it all of the data, and it will just figure out. Is giving AI too much credit. It's not magic, and it's only as good as the data structure. So the process logic and the operational knowledge behind it. So you need to make sure to not over-rely on the model. And then finally, not having a feedback loop. With AI models, they can't just set it up and forget it. Your process is going to change. And as your process change, the model needs to change. So it's important to continue to feed it new data and adjust as the operation changes. Without a continuous improvement cycle, even a strong model is going to become outdated rather quickly. So these are just some challenges and things we want to avoid as we're looking into AI. And the good news is a lot of these things are solvable. And as you know, if we start with a strong foundation and we keep these in mind, then we can avoid some of these pitfalls. So with that, I'll go ahead and hand it over to Scott to talk about what a healthy ecosystem looks like.
Thanks, Molly. Yeah, let's go ahead and dive into it. So the first, and I would argue probably the most important aspect of a data ecosystem that's ready for AI is a subject matter expert that can really serve as that link between the data science world and the operations, boots on the floor world. This is somebody that understands the process, understands the real problems and the real challenges that the operations are facing, but also kind of has a view into the world of the data that operation is producing and how it might be useful for an AI model. The one thing this person really is going to have to spend some time on is defining the problem that they want to solve with AI, because clearly you need to have a goal in mind when you start down the journey of AI integration into your systems. So this person obviously is going to have the best understanding and ability to define that. And then the next thing that's important is once they've added the input data, they've trained a model and got it built, and it enters a validation stage. That person needs to be able to compare those model results against real world first principles understanding of the physics or the chemistry or whatever you're modeling in the process, and be able to say, yes, this model is producing valuable, and what appears to be correct information, or we've all heard the term model hallucinations. It is always possible for something to be mathematically correct in a model engine, but physically completely impossible. So that subject matter expert can identify those things and sort through them. And then the last thing that person is really key for is developing a plan and a process to take the AI model outputs or results and turn them into actionable things that can improve the process. I like to call that operationalizing the model, turning it into something that really works. So now let's talk about the data ecosystem and what makes it ready for AI. And I say that the first thing, kind of at the base level, is really that reliable data historian. And you may have more than one, right? It may not be just a single historian collecting your data from all of your systems, but AI in general, not in every case, but in general, requires pretty high resolution, long-term data in high volumes. So you need a high performance data historian. Unfortunately, a lot of the kind of integrated, DCS or control system historians that only store a short duration of data and those type of things are just not going to be satisfactory. You're going to need something with a much more dedicated, high performance capabilities. And this is going to be not only to collect the data, so you need to be able to continuously collect the data from your automation systems using store and forward technology to put it into the long-term history, so that if there's ever any network outages, you don't have a historical data loss. But then also on the other side, the historian needs to be able to rapidly and reliably serve that data to the users, which an AI application is typically a heavy data user. So it needs to be robust for that. And the other thing to keep in mind is that AI applications often need long-term data history with high resolution for training. So if your data historian is set up, in such a way that everything over a month old gets kind of recalculated into 1 hour averages, and that's all the data you store for long term, your AI training may fail because you don't have a high enough resolution for the requirements. So the next thing to consider, and I mentioned a moment ago, is you might have multiple sources of data, right? So you may have multiple historians, you may have laboratory data systems, you may have MES systems, you may have, a whole host of different data silos, and that can occur because of the way a company has grown over the years by adding new and different systems, or maybe they've acquired assets. But regardless, you need to integrate and aggregate all that data into a single data model. And so that's where some kind of platform that's able to connect to all those different data sources and bring them together into a single point source, essentially, for the end users, is very, very valuable. And it allows your AI tool to make a single connection to access all the data it needs versus having to build multiple connectors to different systems into the AI model and then try to sort through where to find each type of data. And that's just really not usually successful. The other key thing that's important is a single integrated data platform that centralizes all the different sources can also time align those sources into a single kind of source of truth for the timestamps for all the data. And again, in a lot of AI modeling, that time series data is really important. And so everything being lined up on the same time scale is very beneficial. So Molly already touched on the importance of this, but I just want to kind of come back to it for a moment, and that's the idea of contextualized data. This idea started a while back, mostly for the benefit of people working with data, right? And that's the idea that data that's organized in an asset-based hierarchy is much easier to understand and work with and analyze than a sort of flat data structure where you just have a single large tag list of data points and they're not really organized or associated with equipment specifically. If you can create an organized tag hierarchy or asset hierarchy, excuse me, and then tie your data tags to those assets, and then also utilize a consistent and logical tag naming and tag description scheme throughout your database, it's going to make, obviously for humans, but also for AI programs, it's going to make accessing that data and sorting through it for the purposes of analysis and calculations much, much easier. The other thing that's really nice about a contextualized data model is you can include metadata. So these are not necessarily variable tags from your automation system, but maybe they're just items you store in that tag or that data model, like materials of construction for pieces of equipment or sizes of equipment or things like that, that can then also feed into an AI model to help determine relationships between different types of assets and how they perform. So again, this standardized data model on an asset type hierarchy is something that will really help drive your AI project faster and more effectively. Next thing to consider, and this is really a prerequisite now for any data project in the modern world, but data has to be secure and access has to be controlled properly for any kind of confidence to be held in the system. So you want a data system, a data platform that allows role-based access control, that allows encrypted data transfers. And if you think about it, you could set up an AI system that's a third party to that data system and give it a specific AI role. So it only has access to the data that it needs. and nothing else. And when you consider the fact that a lot of these AI engines are based on cloud platforms, that means that you are sending your data across the internet to a cloud server somewhere to for the AI model to run its number crunching and then return results. So you definitely want that as secured properly, including the return, because if you're moving something from an AI model back into your data system, which we'll talk a little more about in a few minutes, you want to be able to audit that. You want to know when it did that data right and where it came from, and you want to be able to see if anyone's trying to tamper with that or anything. So again, a secure and flexible data governance system is going to be key to AI model success. So the last thing I want to mention here is kind of the nuts and bolts of integration of AI systems with your data platform. The reality today, as much as we would like for there to be a single standard open platform, or excuse me, open protocol for all AI models to integrate with data systems, it just doesn't exist yet today. We haven't settled on any one thing. So you want a data platform that is flexible and supports a wide variety of open communication protocols. Things like OPC, REST APIs, SQL, the list goes on. But the more of those that your data system supports, the more likely you are to be successful with AI, because different AI models are going to require different protocols, and that's sometimes by design, because some AI models require streaming data at high frequency coming from the system, and that's best done with something like OPC, whereas other AI models might be looking at more long-term trends, and they may only be taking a daily data extraction from your system or something like that, and that's probably better done with SQL or another protocol. So the bottom line is that you just want to make sure that you don't paint yourself into a corner with a data system that's not flexible, and also with a data system vendor who isn't looking to the future, right? Because you want to have good confidence that whoever's providing you that software is frequently providing updates and adding the latest data connector protocols as they come out, so that AI can be implemented, with whatever it may need to connect with in 5 or 10 years down the road. So now I want to spend a few minutes talking about a real-world example of an AI application, and kind of how you can see the potential benefit. This one has got to do with an anomaly detection that would be used in a preventative maintenance scenario. So let's go ahead and take a look at the next slide. So what we had was a chemical mixing process. Not a super complicated process, but a handful of different chemicals being added to basically a stirred tank. And the stirred tank, it was a slurry tank, right? So there were solids and liquid in this tank that were mixed, and then it was pumped away by a discharge pump. And the process, of course, as we discussed previously, as a subject matter expert that understood the process and understood the dynamics of the different chemicals being added, put together a list of input tags, and then built an AI anomaly detection model. So an anomaly detection model essentially, in this case and in other cases, takes a set of process inputs and simply compares them all to each other statistically to determine, based on some normal operation training data, what's the kind of the standard range for this process. When is it running at its normal and desired conditions overall? And then it calculates what's called an anomaly score. And that anomaly score is 0 whenever that process is running in that standard desirable range. But if a set of variables or the relationship between some of the variables starts to deviate from that normal operation, that anomaly score starts to increase. And you can see here on this trend that the anomaly score is in green, and it did start to increase on about April 5th on that time scale there. And what was happening here, unbeknownst to the operators, was that the agitator on that slurry tank had failed. The motor had tripped out. And this was just a local start-stop out in the field. There was no automation connected to this agitator motor, so there was nothing indicating in the control room that this had occurred. And the process continued to run for a little while because the solids buildup at the bottom of the tank was not too fast. But some of the other variables in the process started to indicate to that anomaly score that something was wrong. And so the anomaly score started increasing. And it steadily increased over a couple of days and got to a point where, it hit its maximum value. So the AI model could see that the process was far from its normal operating condition until finally, about 4 or 5 days after the agitator failure, so much solids had built up that they plugged the suction of the discharge pump, and the discharge pump shut down, and the process had an unplanned downtime. So this particular model was not operationalized yet. It was in the model validation stage. So operators did not get any indication of this anomaly score increase, and so they didn't know to do anything about it until it was too late. But we can see from the trend and from how early that anomaly score started to increase that had the operators been alerted to it, they would have had several days to be able to get out in the field and get that agitator running again, and potentially completely avoid an unplanned outage. So to look at this a little different way, this is just kind of a flow chart for how this particular application of AI would go. So in this case, the customer had DataPARC as their factory data platform. So DataPARC connected to the AI tool and sent first historical data for AI model training. And that's where that subject matter expert would identify the periods of normal operation and the inputs that are important to that process unit, train that model. And then the other thing to point out is that once the model is online, the training is not ever completely finished. Either you can set it up either automatically or have it be on demand by an expert. It depends basically on the AI model being used. But at some point, on some cadence, the model should relearn. It should be retrained to update that normal operating condition model. But in any case, the anomaly score from the model then can be exported back to the data system where you create a tag that represents that anomaly score. And then to operationalize, and this is the step that hadn't occurred quite yet in the example we were discussing, but to operationalize that, then you would set limits and an alarm on that anomaly tag so that anytime it exceeds a certain number, it's alerts the operators and sends notifications to the proper folks so that they see something is happening and they can take action to avoid that unscheduled outage. So again, this is just kind of an example. Obviously, there's different types of AI models. Some of them might not be anomaly detection. Some of them might be, prediction of process outputs or other things. So, but I do think this example gives a good simple way to kind of wrap your head around the potential and the benefits that you can realize via AI. All right, and that's about all I have for the moment. I'll turn it back over to Molly.
Great, thank you. Now I just wanted to briefly touch on how DataPARC can support your AI journey. So first, the most fundamental piece would be a high performance data historian. This is where it all begins. If you're currently only relying on a SCADA system or GCS, and you don't have that long-term historical data collection in place, you're going to run into challenges with AI. DataPARC's historian is built to collect real-time data, including sub-second intervals, so you don't lose any of that resolution or context. So when you're training and validating models, you have all of the data you need. So you can't analyze what you haven't collected, and you definitely can't train the accurate models on inconsistent or incomplete data. So having a historian and having that data collected is really important, and that first step. Secondly, a data integration and having a centralized data structure. So as we mentioned earlier, getting your data out of silos is critical, and one of DataPARC's primary functions is designed to pull all of the multiple sources from wherever you have, whether it's historian, MES, LIMS, and consolidate them into a single source of truth and create that centralized structure so that you can export that data to maybe a third-party AI, and you can make sure you have those matching timestamps instead of wrangling different CSV files from multiple different systems. And then you can, re-import that data back into your single system. So everything is clean and synchronized and available in one place. That is, DataPARC's primary goal. So data integration is key there. Another way DataPARC can support your AI journey is through asset-based tag organization and asset modeling. So it allows you to group and organize tags based on their function, very intuitive for engineers, and it's scalable. So you can create one model and then reuse it for different assets. You're able to use this within ParcView as well. To, say you have a bunch of different pumps, you can select one pump in a trend and then select your other pump and all the tags will just come through. So that is another tool. And one function we may not have touched on too much earlier, but is still important to note, is visualization and analysis. So with DataPARC engineers and those subject matter experts, don't need to export data from third-party tools to just understand what's happening. They can use the platform where the data already is to build XY plots, Paretos, histograms, and even trend to validate the model performance directly within the system. So they don't need yet another system to export the data to do more analysis on it. So not only is it visualization, but there's also analysis tools. So it helps encourage more data-driven decision-making. And then lastly here, we have the integration with AI platforms. As Scott mentioned, it's important to stay flexible with a wide range of protocols. So with DataPARC, you have the ability to connect with SDKs, APIs, SQL. So you're not limited to only being able to connect to one AI vendor or locked into a proprietary ecosystem. You want to be able to maybe choose a variety of third-party analytics providers. And DataPARC makes it easy to be able to extract the data the way you want so that you can use whatever vendor you want. So that brings us to our takeaways. And to wrap up the major points we want to leave you with is that AI success is going to start with a strong data foundation. The data needs to be structured, centralized, and accessible. And without this, AI simply cannot deliver useful insights. AI is not strictly plug and play. You need to have your data clean. You need a subject matter expert and flexible integration. Those are all non-negotiables, and even the best models can fail without them. Again, subject matter experts are essential. They're going to guide the problem definition. They're going to validate the results and turn those results into action. So they're going to amplify the AI, and AI is not going to replace them. And then finally, DataPARC can help bridge the gap and help build your foundation for your data ecosystem and build your AI-ready environment. So for high-speed data collection to visualization and integration, our platform is designed to help you collect your plant data to modern AI tools. And with that, I think we'll see if we have any questions. And it looks like we do. So, Scott, I'll go ahead and ask you the first question. How much historical data is needed before starting to use AI?
Okay, well, that's an interesting question. Unfortunately, there's not a single straightforward answer because, and this is going to come back to that subject matter expert taking a look at the process, because it's going to depend on, well, both the process character and the type of AI model that you're building. So let's say, for instance, like the example we gave earlier, we're building an anomaly detection AI model. And so the training data set needs to be essentially normal operations. And we want to capture whatever the range of normal operations are. If this is a process area that runs with very consistent feedstock, and it responds to process changes on the matter of just a few minutes, then you may only need a week or two of historical data to train a model for that process area. But going to the other extreme, if this is a process area with a long time constant, so it might take 12 hours or 24 hours to see the results of an input change, or perhaps the inputs are seasonal in nature, so the raw materials change dramatically between winter and summer, then you might need 1 or 2 years of historical data to train that model. And then there's other types of models too, right? It's like I mentioned earlier, we could be talking about a process response model. So instead of trying to train it on only normal operating data, we're training the model on response to changes in inputs. Well, then we need to make sure that our historical data set includes all the typical changes that operators might be making throughout an operating season or cycle. So you really need to, again, engage that subject matter expert, consider the type of model that you're trying to implement, and also the process character and the time constants associated with it when determining how much historical data you need.
Mhm. Yeah.
All right. I do see another question that came up here. How do you handle resistance from engineers and operators who are skeptical of AI? Any thoughts on that, Molly?
Yeah, that's a good question, and a common one. I think people are definitely either on one side or the other. They're going to be skeptical or really excited about it. And I think the key here is not to push AI as like a magic solution, and not to put people into the position as it's going to replace them, and that their expertise as engineers or operators is not important. They know the process very well, and it's important to use them to help define the problem and get them involved early. So help them define the problem, help them select, use them to help select the data, and for the model validation. All of that goes a long way. Get them involved in the process and help build trust, to ensure the outputs are relevant. Another thing you can do is see if there are any quick wins that you can use AI to help leverage, like if there's a way to help reduce downtime, or find a flag problem, or like flag a problem that's causing shutdown or something, and maybe that can help reduce some skepticism, and help bring out some curiosity. So if there are some quick wins, then that's another way. This can, you want to have transparency in how AI is used, and have it be an extension of their workflow rather than just be a black box of decision making, and say like, this is how it's going to be. You want them to use it as a workflow instead of dictating what's happening. And then here's another question that's coming through. So once the data ecosystem is set up, so the site sounds like they have a strong data ecosystem set up, what is the next step going to be? So how do they actually utilize AI once their data ecosystem is set up?
All right, I'll take a stab at that. Thanks, Molly. At the risk of sounding a little bit repetitive, it really comes back to that subject matter expert, right? So, you feel like your foundation is strong and your data is contextualized and it's accessible and everything is ready. And it's tempting to go out and start looking for AI tools immediately. But I think what's actually more valuable is to take a step back and look at the process and look at the system that you're, in your operations, and what are the pain points? What are the problems that we can't solve with the existing tools that AI might be able to solve? And you might want to do a little general research on, what is AI capable of, right? Because you might identify a problem that AI is not going to solve either. But the point is that the initial AI implementation needs to be led with identification of a problem or a task that needs to be solved, and then see, is there an AI solution that can help with that, and then go find a product and then make that connection and build the model and implement it. Because what you don't want to do is you find a kind of a flashy AI tool that has great claims and can connect to your data ecosystem, and then spend a lot of time and effort installing it and building models and putting it online, and then start asking yourself, well, what problems can I solve with this tool? Because then you may find yourself having spent a lot of time and money, and then actually not deriving any value because the tool isn't actually pointed toward the problems that you have. So again, I think that next step is really going to be that someone or some group of people with a lot of experience and expertise in the process or the operations that you're running, to determine, what problems can we solve, what pain points can we alleviate with an AI tool.
Yeah, that's a really good point. Well, I think that's the time we have for questions today. If we missed your question, we will definitely get to it via email. So keep typing them in. There's also a survey at the end, so you can type in more questions there. Again, this recording will be on YouTube. So yeah, thank you so much for joining, and we will catch you on the next one. Have a good day, everyone.